Dear students, welcome to my channel Do Maths Perfect. Today I am taking science class Valency and Isotopes. The number of electrons in the outermost shell of an atom are called valence electrons. For example, hydrogen having one electron in the outermost shell, sodium is having one electron in the outermost shell, carbon is having four electrons in the outermost shell, chlorine having seven electrons in the outermost shell. So those are called as valence electrons that we explained in the previous class. So chlorine has 7 electrons in the outermost shell. So chlorine atom has 7 valence electrons. They are called as valence electrons. Similarly, sodium has 1 electron in the outermost shell. So sodium has 1 valence electron. So let us take another example. Carbon, it has 4 electrons in the outermost shell. So carbon has 4 valence electrons. That is valence electrons. They are very important in the chemical reaction. Valency, the combining capacity of an element is called its valency. Combining capacity means one atom of one element reacts with other atoms of the element in definite proportions, that too by giving electrons or by taking electrons. That is combining capacity. That capacity depends upon the number of valence electrons. Let us learn more about it. First of all, Bohr's rule, that is octet rule. What is the octet rule? Elements having completely filled outermost shell are quite stable. This is known as octet rule. That means if an element except helium is having only one shell, so it completely filled with two electrons. Its valency is 0. For other elements, for all other elements, they are tending to get octet. By giving or by taking, they become a stable atoms. That means elements having completely filled outermost shell. That means if there are 7 electrons in an atom, it is very active to take one electron. For example, if one electron in the outermost shell, it is ready to give out one electron. So thereby taking or by giving, it tends to get octet. That is octet rule. Octet means 8 electrons in the outermost shell. Then only it becomes a stable atom. For example, sodium has one electron in the outermost shell. So, during chemical reaction, it can give its one electron to other atom of an element and becomes a stable ion. So, valency of sodium is 1. Because sodium has 11 electrons, first shell 2 electrons, second shell 8 electrons, the 11th electron, that is in third shell, it is having only 1 electron, that is valence electron. By giving its 1 electron, it becomes octet. Dear students, we learned the electronic configuration. For example, now let us take unknown elements. Let A is an element having atomic number 5, that Z equal to 5. Atomic number 5 means number of electrons 5. It is having 5 electrons. How they are distributed? First shell 2 electrons, second shell 3 electrons. So this is the outermost shell. Therefore, these 3 is the valence electrons. and these 3 is itself the valency of that element, because it can give out 3 electrons in the during chemical reaction. Come to this B. B is having 8 atomic number. How they distributed? First shell 2, second shell 6. So this is the outermost shell. 6 electrons are there, valence electrons they are called as. So it requires only 2 electrons. Therefore, to get octet, this takes 2 electrons. Therefore, the valency of this B element is 2. That is where we recorded 2. Now come to this element C. It is having electrons 12. That means atomic number 12. How this distribution? First shell 2, second shell 8, third shell 2, 2 plus 8 plus 2, 12. This is the outermost shell. This having 2 electrons. These 2 electrons are transferred to other element during chemical reaction. Therefore, valency of this third element is 2. Fourth element, let it be 8, D. Its atomic number is 18. That means 18 electrons. How they distributed? First shell 2 electrons, second shell 8 electrons, third shell 8 electrons. 2 plus 8 plus 8, 18. So the outermost shell is completely filled. That means it is in neutral state. So its valency is 0, because that does not participate in the chemical reaction. Now come to this atomic number once again, that is Z. The number of protons in the nucleus of an atom is called its atomic number. It is denoted by Z. Aluminium, this element symbol Al, atomic number 13, that means Z equal to 13. That means aluminum nucleus is having 13 protons. That is nothing but a atomic number 13 protons. Sulfur, atomic number is 16. 16 protons, nothing but 16 electrons. This 13 protons means nothing but 13 electrons. That is atomic number. Now, atomic mass. Mass of an atom of an element is called as atomic mass. Mass of atom of an element is called as atomic mass. One atom mass of carbon, that is nothing but protons plus neutrons of a nucleus. This carbon nucleus having 6 protons and 6 electrons. Therefore, atomic mass of carbon is 12. Atomic mass nothing but mass of nucleons. We call the sum of these two is called as nucleons. In all the cases, we neglected electron because its mass is very less compared to that of proton and neutron. So mass of electrons is negligible. Atomic mass of nitrogen. Nitrogen nucleus, one atom of nitrogen nucleus having 7 protons and 7 neutrons, that is equal to 14. Atomic mass is 14. Isotopes. Iso means same, topes means place. In the periodic table, we are arranged the elements according to increasing order of their atomic number. Here, the mass of atom of an element are different. Certain numbers are, certain elements are like that. Let us see the isotopes. Atoms of the same element having the same atomic number but different mass numbers, such element is called as isotope. By taking example, we can understand the meaning of isotope. Once again, I will repeat, atoms of the same element having the same atomic number. Atomic number is same, but different mass numbers. Such elements are isotopes. Hydrogen is an isotope. Carbon is an isotope. In this way, some elements are their isotopes. So let us take one example of hydrogen. Protium, that is nucleus having one proton and only one electron in the first shell, that is hydrogen, we call it as protium. Same hydrogen, if it is having one proton and one neutron in the nucleus, we call it as deuterium. Having one electron in the first shell, its atomic number is 1, but mass is 2. Here the atomic mass is 1, here the atomic mass is 2. Come to this tritium, nucleus contains one proton and two neutrons. Atomic mass is 3, but the atomic number is 1. Electron is also 1. Such masses are different. Atomic number of hydrogen is 1, but atomic mass of protium 1, deuterium 2, tritium 3. Such elements are called as isotopes.